Okay. Hello, hello. Welcome. My name is Jerry, and I'm going to be your teacher today for our free prep hour. And what we're going to focus on today is coordinate geometry. Now, this is one of those topics that oftentimes it shows up just enough that it can be a problem if you struggle with it. It is one of the topics that, like, if you really find what we do today hard, you might say, okay, maybe I'm skipping most of the coordinate geometry I see. But it seems like more and more, this is a topic that shows up on the GRE. And if you don't have familiarity with it, even at least for the basic kinds of questions, you're going to have some trouble. So what we're going to do today is go through starting with the basics and working up to with increasingly difficult GRE style problems. As we do that, if this is your first time looking at anything on the GRE, welcome, hello. We'll get to see some of the problem types that are involved and talk a little bit about some general ideas about how to take the test. And at the end, I'll open up for questions about anything we're talking about. So to start with, coordinate geometry. One of the many pieces of geometry on the test. Geometry is a big subject here. You know, other things include circles and triangles and cylinders and stuff like that. But coordinate geometry is whenever we have the coordinate plane. And sometimes the coordinate plane always looks like this. We got our x-axis going horizontally, our y-axis going vertically. Sometimes it will be unmarked. Sometimes it will be marked with ticks and you can actually count it out. And on the test, it actually doesn't really matter if it is marked or unmarked. In both cases, this is the only time on the test in geometry that things are drawn to scale. So no matter what, you can trust your eyes. And a really good idea is to, when you see a coordinate geometry problem, just sketch it on your paper as best as you can. Today, we're going to be working with visual solutions as well as mathematical solutions. So I want to try to give you the tools to approach these in different ways. But either way, drawing things is going to be really helpful. So to start off, warm us up, I've got a couple like short little quizzes just on some of the basic mechanics here. If you don't know anything that I'm putting on the board, that's totally fine. This is just to introduce some of the fundamental concepts and that we'll start using in the problems. So to start with, we have here an equation, and this is the equation for a line, although the hint I'll give you is it's not really in the form that we like to use for an equation of the line. And I've got 5 questions here for you. When you have the answers to those, please let me know in the chat. I'll give you a few minutes to work on this. Oh, and if you're totally stuck, let me know that you have no idea how to do it, and that's fine too. Okay. So when we're looking at this, the first thing that we need to do is to, sorry, I'm just trying to annotate here. First thing that we want to do is to take this equation and put it into our standard equation form for coordinate geometry, which is y equals mx plus b. And this is helpful because these two values, m and b, become really important for understanding how the line works. So m is our slope. We'll talk a little bit more about what that means in a second. And b is the y-intercept. So when I've got a coordinate plane, I have my x-axis and my y-axis, and the slope of a line is basically what angle is the line moving at. And slope is equal to rise over run, or the change in y over the change in x. Yeah. Change in y over the change in x. The y-intercept is where the line crosses the y-axis. So in this case, y equals negative 2/3 x plus 2. Our slope is going to be negative 2/3. And that's going to look something like this. A positive slope goes up from left to right. A negative slope goes down from left to right. A slope of 1 is at a 45-degree angle, exactly splits the x and y axes. Negative 1, 45-degree angle going the other direction. This is negative 2/3. So what that tells me is it's a little bit less steep. The bigger the negative number, the steeper this line would go. But negative 2/3, it's going to be a little shallower. So something like this. But then we're asked, what's the y-intercept? For that, we just look at b. In this case, 2. Okay, so if I'm going to sketch this line, here, let me get rid of this blue one. I would say, okay, it's got a negative 2/3 slope, and the y-intercept is about at 2. So here would be my sketch of this line. Now for the x-intercept, what I'm going to do, the x-intercept would be right here, where the line crosses the x-axis. And that's going to be where y is equal to 0. So to find the x-intercept, I would set y equal to 0 and say 0 equals negative 2/3 x plus 2. Subtract 2 from both sides. Multiply both sides by 3. Divide both sides by negative 2. Now, why am I getting something different here? Feel free on the chat. If you see my mistake, let me know. I think this is incorrect. And I'm going to say, apologies that my slide is wrong, but that this should be 3, 0. Now, slope of a parallel line. Parallel lines have equal slopes. So a parallel line would also have a slope of negative 2/3. And that could look like anything like this. These are all different parallel lines. The slope stays the same, but the y-intercept would be different. A perpendicular line has a negative reciprocal slope. So flip it upside down and negate it. So in this case, our negative 2/3 slope becomes 3/2. And that might look something like this. Perpendicular meaning it makes a right angle at the meeting point. Okay, a lot of information here, I know. The big one to hold on to is this right here, y equals mx plus b. If you get your equation in that form, suddenly you can get a lot of information. Any questions about this? I'll say as I'm going, please feel free to send me questions either in the chat or in the Q&A. I'm here to clarify as we go. So a couple more fundamental things. Now that we've talked about this some, I want you to see if you can find these two things. This one, we've already talked about this. We haven't, it's a little trickier. And then see how well you understand the idea of what a slope is and list a possible slope for these. Let me know when you're done, please. Okay. So for this first step, if we're thinking about the slope or the distance, so remembering that the slope is going to be the change in y over the change in x. It can be helpful to think about thinking about what's the change in the y, what's the change in the x. We might notice if we draw those on here, we end up making a right triangle. So the slope is just going to be that change in y over the change in x. So 6/8 or 3/4. Noticing, of course, that it's positive going up this way. To get the distance between the points, here we need to think, okay, this is a right triangle, and the hypotenuse is the distance on the line. So we can treat it like a right triangle. And maybe we recognize that this is a special right triangle, a 3, 4, 5 triangle, or maybe we instead use the Pythagorean theorem. A squared plus b squared equals c squared. Knowing that c squared is our distance squared. Oh, why did I write this instead of type it? And so we could do this as 6 squared plus 8 squared equals our distance squared. So 36 plus 64 equals distance squared. 100 equals the distance squared. So 10 equals our distance. So you can just think of it like the hypotenuse of a right triangle. Now over here, line number 3, we first want to notice it's positive and it's steeper than the 45 degrees. So this has got to be greater than 1. 4 is positive at 45 degrees. That's our slope of 1, y equals x. Here we've got negative greater than, less than 45 degrees to there. So between -1 and 0, whereas 6 would be our -1. Having a sense of being able to eyeball these, very, very helpful. So again, let me pause for any questions before we start looking at some GRE type problems. Okay. So take a deep breath. And this is kind of a warm-up problem, just to make sure you understand how this coordinate plane idea is working. From there, we're going to start getting into a little bit trickier material. Send me your answer here when you have it. Okay, so here we've got our line. Notice it's a negative slope, steeper than 1. Here they've labeled everything. So we're looking for the point that has an x coordinate of -3. This is really just to make sure you understand how the xy axis works. Here we've got our -3x. If we draw that down, what is the y coordinate that we get? Right about here at -4. And so that's our answer, -4. This is a little more straightforward than the kind of thing you'll see on the GRE. But again, this is just to make sure we understand the concept of how to read the coordinate plane. Now, let's get into some GRE problems. So before I release you on this problem, I just want to point out something about the format. This is called a QC, or quantitative comparison problem. In these kinds of problems, you're going to get some kind of info here. Sometimes they don't even give you anything. And then you have these two columns, column A, column B. Your job is always the same. You are comparing the two quantities. So I don't actually care what this value is or what this value is. All I care is which is bigger, or are they equal, or can it not be determined? Send me your answer when you have it, please. Okay. So looking at these two lines, first thing I might notice is that they're both negative. And so the question becomes, which is more negative and which is less negative? Now, remembering that a line that goes at 45 degrees is going to be y equals -x. This is a slope of -1. We want to think, okay, this one, which is closer to being horizontal. And if we think the horizontal line is y equals 0, so a 0 slope, we can think of it as going from -1, we're getting closer and closer to 0, and then we're going up until we have 1, and then more and more and more until this would be a slope of infinity. So going from this -1 slope, we're getting closer to 0. That tells us this is going to be in between -1 and 0. Whereas this, more negative, more steeper. The slope here has got to be greater than, less than -1, more negative. So we have something less than -1 and something between -1 and 0. Quantity A is going to be bigger. Maybe a little confusing here because this is like the bigger number, but it's a bigger negative number, right? So this could be something like -10. This could be something like -0.5. And now you've seen a QC problem. We're going to see some more of those. Let's keep going. Again, feel free to ask questions in the chat or in the Q&A whenever you have them. Okay. So, problem like this, they don't give us any scale here. So we can't actually calculate the slope of this line or the equation of the line. We just have to use our understanding of y equals mx plus b, remembering that m is the slope, b is the y-intercept, to say which of these could it be? And so we want to look at this with an eye towards process of elimination. So looking at this, I notice my y-intercept is negative and my slope is positive. In a very rough way, that's what I see. So let me see what I can get rid of first. Well, E has got a negative slope, so I'm going to get rid of that. D has got a positive y-intercept. Let's get rid of that. A also has a positive y-intercept. So now I have to look at these two and say, which one is more likely? Now, I'm not going to be able to judge based on this y-intercept because I don't know what the scale is here. Instead, I'm just going to have to use the slope. Keeping in mind, this is a steeper slope. This is a slope of 1, so it's going to be at 45 degrees. And you know what? That's what I've got here. This is a 45-degree m equals 1 line. So my answer is going to be C. As you do these, you want to try to get an I for that approximately 45-degree line. A line that had a slope of 4 would be much steeper. It would look something like this. So you want to just have a sense of that. So we see here, understanding how the equation works, but being able to do a visual solution is the key. Let's keep going. Send me your answer when you have it, please. Okay, so we are here asked for the slope. Keeping in mind the slope is the change in y over the change in x. Let's do that here. So it passes through -4, 5, and 1, 2. Let's just sketch this here. Helpful to get a sense of what's going on. So -4, 5, something like this, and 1, 2. So I'm expecting a negative slope, first of all. So we have 2 minus 5 over 1 minus -4. So we have -3 over 5, which is choice A. Now, what if they asked us for the equation instead of just the slope? if they wanted the equation, well, what we would need to do is first find the slope. So if we have that, m equals -3/5, great. We then would need to say, all right, if y equals mx plus b, and I know my m is -3/5. What I would then need to do is take one of these two and substitute them in for x and y. Because what this line is all of the points that satisfy this equation. So if I know this point is in the equation, I can plug it in and solve for b. So let's do that. Let's say y equals 2 and x equals 1. And add 3/5 to both sides, call it 2 and 3/5 would equal b. Or of course, we could make that 18/5 equals b. So keep in mind, you can always plug points into the equation. It's going to become helpful as we keep going. Maybe right here. So try this out. Send me your answer when you have it. Okay. So to find a line, first we find m, and then plug a point in and find b. So let's get m here. Remembering m is the change in y over the change in x. Say 6 minus 0 over 0 minus -4. And it actually doesn't matter which one you call y1 or which one you call y2. The only thing that matters is that you're consistent about it, right? So if I say this is y1, or this, in this case, I'm calling it y2, this is also x2. Great, so I get 6 over 4, or 3/2. Now, I'm going to say y equals 3/2 x plus b, and let's pick one of these to plug in. How about this one here? 6 equals 3/2 times 0 plus b. That's nice. 6 equals b. Now, I might have gotten here a little bit quicker if I had recognized that b is my y-intercept. And here, they actually give me my y-intercept. So I could have maybe skipped this step. Let's keep going. A little bit harder this time. Send me your answers when you have them. Okay. So, apologies for the bells in the background here. I would start by sketching this. So, put in -2, -3, something like this, and it crosses the y-axis above the origin. The origin meaning 0, 0. So something like this. Now, it could be a lot steeper. It couldn't be like this. And so as I think about this, I would say, okay, I know it goes through this point, and it's got to go through a point more than 0, 0. That doesn't mean it has to go through 1, 0. Just that the y-intercept has to be greater than 0. So my strategy here is I want to figure out what would be the slope if it went through 0, 0, and then know that it has to be greater than that. That would be pretty easy to find. 0 minus -3 over 0 minus -2. That would just give us 3/2. So that tells me m has to be greater than 3 over 2. So I'm going to get rid of anything that's not greater than 3 over 2, which has to include 3 over 2. Because if the slope were 3 over 2, it would go through the origin and not above it. So my answers are D, E, and F. This can be a tool we use in the test, right? We solve for the lower boundary and keep in mind that it can't actually be that value. Let's keep going. As you see, these are getting increasingly difficult. Keep it up. Let me know if you're stuck. Let me know if you have questions. Let me know your answer when you have it. Okay. So here we're going to use our slope formula, but we're going to use it kind of backwards. We know the slope is -2, and that's going to be the change in y over the change in x. So -2 equals y minus 9 over 2. Multiply both sides by 2. Add 9 to both sides, and we get our y equals 5. So same formula, just using it a different way. Something we need to expect in the GRE. We're going to know all the rules, but you have to be prepared to use them in unconventional ways, depending on exactly what the question is asking. Got time for a couple more. Okay, so we could sketch this in, and maybe that's going to help us a little bit. Let's find out. It's usually how I like to start. So a slope of 2 is going to look something like this, minus 8. So starting way down there. Now, just looking at this sketch, negative 8 comma 0, that would be like over here. That's not going to work. Now, what about 3 comma negative 2? I mean, maybe, I can't tell from my sketch. Or 1/2 negative 7. It's in sort of the right area. In this case, I'm just going to have to plug things in. So let's check 3 negative 2. Negative 2 equals 2 times 3 minus 8. And that works. Because that lines up, that means that's in the line, and that's good. Let's try the other one. That also works. So C is also going to be correct. Now, just to show you what would happen if we tried something that didn't work, let's take a look at this. 0 equals 2 times negative 8 minus 8. I would get a result that doesn't make sense. Saying, for instance, 0 equals negative 24, which it clearly doesn't. And so this would not work. We've got time for one more, and then we'll end. I'll take some questions. Okay. So the first thing to notice, unless they tell you choose all that apply, it's only going to be one answer. So we want to know which one does not lie on the curve. And it's very easy to get lost in something like this. And now this is a curve, and this is not a line. And if we had more time, I'd get more into how curves and parabolas work. But for our case here, I can just recognize, okay, this isn't y equals mx plus b. This is something else. What it actually would look like is this. It would be a parabola. that might look something like this. It would intersect at y equals -3, be facing upwards like this, something like this. Now, if I could sketch this, which I just did, that could help some. And I might know, for instance, that C is not going to work. But because I didn't go into how to do this, what we'd have to do here is just plug stuff in and see if it works, same as we did before. So 6 equals 3 squared minus 3. Is that going to work? We get 6 equals 9 minus 3. 6 equals 6. This is on the curve, so we don't want it. 6 equals -3 squared minus 3. Again, 9 minus 3 equals 6. That is also on the curve, so again, we don't want it. Here, -3 equals 0 squared minus 3. That also works on the curve. We don't want it. 0 equals -3 squared minus 3. So 9 minus 3 gives us 6. Aha! This doesn't work. It's not on the curve. It's what we want. And just to test this last one, -2.75 equals 0.5 squared minus 3. 0.5 squared would be 0.25 minus 3, which would be -2.75. Also falls on the curve, not our choice. So even though we're dealing with a different kind of equation here and a different kind of figure, we still use the same technique, plugging in and checking. So that's all the time we have for today. I hope you found this helpful. Like I said, this is only one of the topics you're going to see on the GRE, but hopefully you feel a little stronger on it. I'm going to end our recording now, and then I'm happy to take some questions.